Hi, my name is Joshua, and I am working on a CAS project basically about programming, learning a little bit more Blender and game creation. Currently, I am working on understanding how scenes like these, this is the game No Man's Sky, how terrain is generated like this. Many games use varying methods. This is No Man's Sky, for example. Here's another picture of terrain generated. You can see little animals in the front, but basically, what I'm trying to show you is the mountainous terrain in the back and how it can drastically differ in the very different images. And here's another picture of a space game called Space Engineers, where they have a similar ish kind of terrain generation. Now you can see now, so you may be wondering, how do we generate this terrain? The picture you see above is of an algorithm that's visually represented, and it's called Perlin Noise. Now, Perlin Noise is basically an algorithm that was invented to make more natural noise. So you can make things like mountains and I don't know, basically anything in nature can be kind of made with Perlin Noise because Perlin Noise is a way to make natural seeming randomness. Above, you're seeing a picture of true randomness. Now, if we used true randomness to generate mountains or so, it would not look natural at all because Perlin Noise, it doesn't account for erosion or such, but it has smooth transitions between, like, as you can see, the darks and the blacks. And if we use those for, say, I don't know, a mountain height or something like that, it would be much more, natural than random. There are also other algorithms, but Perlin Noise is the main one that I'm working on right now. So I started out my adventure by making a 2D Perlin noise generator. Now, Unity already has the algorithm for Perlin noise built in, so I am basically creating a way to view this 2D Perlin noise on something called a quad, which is basically just a square. Now you can see here it is running the script. I have my Perlin noise generator. You can use WASD to scale, zoom in, and out on the Perlin noise function. Um, yeah, this was actually a very interesting project to do, and I used a tutorial by Brackies on YouTube that was extremely valuable to learn how to do this and learn what I needed to do for all of this. And now, and here you can see a view of some of my code. I will also send it to you, CAS Advisor. So at the top we have the width, the height, and the zoom variable, which zoom will allow us to zoom later. The width and the height allow us to make how big the Perlin noise on the quad is going to be. The scale will allow us to scale later, and the offset will allow us to randomly offset on the Perlin noise function and algorithm. We send it to random later, right here in the start function. The update function basically just allows us to constantly update. That's how we were moving on the texture. And here we're generating the texture, the generate texture function. And there's the loop where we go through and generate for each value. The calculate color basically inputs into the Perlin function. And then down here is the movement functions for W, A, S, and D. So I can give it a more in-depth detail if you would like, but this is basically how my 2D Perlin noise worked, and I think I learned a pretty decent amount from it, and I really appreciated the brackets tutorial that I watched on this. So next up, I made it 3D. This is also with the help of a bracket tutorial, which is extremely useful because I don't fully know all about Perlin noise or how to exactly do it. So this is very helpful. Anyway, as you can see, we have some of the similar stuff, height and width like before, but we also have a third, which is depth. So instead of color, now we're having depth as the blacks and whites, which are basically, so where it was black before, there's now a mountain and such. So we're using Perlin noise to control the texture. This is using Unity's in-engine texture generation, and I'm not making my own polygons yet. That'll be probably the next thing I do. But I think I'm pretty satisfied where I got so far. I'm still adding a feature which will allow you to walk around on the terrain you generate. So I have not released the code yet, but it will be in the next update for my CAS. And also, my other project will be in the description, and I can also send you the link to. It'll be on a website called itch.io, which is where games are also hosted and tools and such like that. Some interesting programs are already on there. Anyway, so here's a good look at my code. So as we can see above, we have some of the similar things. We have our offsets. Then we have our update for terrain, which will allow us to constantly update our terrain. Those have the has the two functions inside of it. We have our generate terrain, which I don't fully completely understand all of this, but basically we're creating an array for generate heights, and we're looping through and just like the previous, and then generating numbers for the numbers in the array. And then we multiply our offsets times the widths we get in the bottom. Here, let me go back a little bit. Okay, there we go. So as you can see, at the very bottom, we multiply the width times the scale for scaling, and then we add the offset. And the offset, which this is the exact same as the 2D code, but basically the offset is random. So then you're moving to a random part of the Perlin Noise algorithm. So basically you're just moving. Think of it as if it's a giant picture, and then you're moving left or right, basically, I guess. So yes, this is basically what I've been doing on my CAS project. I have also been practicing a little bit of Blender. That's kind of unrelated, but also at the same time related, because I'm working on making a character that can navigate the terrain I'm generating. Right now it's just a cylinder, I guess you could say. So I was working on some lighting, and I can add those renders in now. Here's a very basic render. I'm basically just trying to work on understanding how to correctly make lighting and things like that in Blender, which will also translate over to Unity, which also uses lighting and things like that. So I could probably use that definitely for my game. Here's another where I am trying to understand how to use the materials. This is a sphere that is using the Voronoi node, which is generating a texture on top of it. I don't fully understand the math equation for that, but it's not really needed to understand it in Blender, because in Blender it kind of does it for you. You just set up the settings, while in Unity, if I'm generating Perlin Noise for land, I have to understand the equation, because I'm literally implementing it. And right here is the little cube animation I did to test my skills with some reflections and some camera movements and things like that. Also a soft body simulation. It's not too hard. I was just kind of curious and wanted to work on it. I did spend quite a lot of time on it to get it to work and learn how to use Blender properly. So I would say in the past week I've probably spent anywhere from I spent about 4 official hours on programming, and then I spent, I'd say, 1 or 2 more hours on Blender and doing stuff like that. So I'd say about 6 hours on this CAS project in the last week. I'm very happy with what I've learned so far, and I'm excited to continue. So thank you for watching, and I hope you have a wonderful day. If you're the CAS advisor watching this, thank you for being my CAS supervisor. And if you're a random person on YouTube that found this, I hope you have a wonderful day too. And Perlin Noise is pretty cool. You should look into it and learn Unity, because it's free and it's a great way to program and use your knowledge. Anyway, have a wonderful day, and thank you all for watching.